Homework 9, compound interest, video 5. How much principal do I need today? I know it's nice to start with some money and see how much you're going to have in the future, but sometimes you need to flip that around. I need this much money in the future. How much should I invest now? For example, a married couple wants to buy a house with cash in 10 years. So they don't want to pay a mortgage, they're just going to say, here's the money. They found an investment opportunity that guarantees 5% interest compounded semi-annually. If they need $200,000 in 10 years, how much should they invest now? So what is it we're looking for? The amount that you start with is the principal. So essentially what we're being asked is, what does P equal? Well, let's start by listing everything that we know. We don't know what P equals, but we know the time is going to take 10 years. So we'll say T equals 10. And we're told an interest rate of 5%. Well, let's go ahead and convert that to a decimal, 0.05. And we know that N, the number of times per year of interest is compounded. If something is semi-annual, then it happens twice a year. So N is equal to 2. What variable does the 200,000 represent? It's not the principal that we're starting with. It's the future value that we want later. In other words, we know the value of A, 200,000. And we're trying to figure out what P equals. Now, is there a formula that says P equals? Yes. Do we need it? No. All we need is a formula that ties all 5 of these letters together, but we already have one. A equals P times parentheses 1 plus R over N, exponent N times T. So how can we use this to find the value of P? Well, there's a couple of things we could do. Number one, we could substitute all the values that we do know and do some algebra and solve for P. Or we could do algebra first, solve for P, and then plug in the variables later. I'm going to go for the second option. Because your choice is do algebra every time you see a problem like this, or do it once and then just use the new formula later. If we want to figure out what P equals, we got to get that by itself. And it looks a little tricky to solve this for P, but if you look at it, if you look at the big picture, the right side of this just says P times something, big chunky something. And from an algebra perspective, the way you get rid of something that's multiplied is you divide. Divide by what? This whole chunk. 1 plus R over N in parentheses to the exponent N times T power. So 1 plus R over N in parentheses, exponent N times T power. So algebraically, it gets the P by itself. And it does create a new formula. I was debating on actually doing this, but we've come this far. The formula for the principal is A divided by that whole chunk. 1 plus R over N, exponent NT. So let's just plug in everything. The A is 200,000. In the denominator, parentheses 1 plus, the interest rate is 5%, 0.05, divided by N, which was 2, close parentheses. In the exponent, it's N, which is 2 times T, which is 10. Now, could you put all this in your calculator? Yes, except instead of hitting times after the 200,000, you would just hit divide. However, I think I can do some of this without a calculator because the numbers are not that bad. I can't do all of it, but I can do some of it. For example, I know what half of 5% is, because I know what half of 5 is. Half of 5 is 2.5. So as a decimal, it's 0.025. 1 plus 0.025 is 1.025. Then the exponent is just 2 times 10, which is 20. So if you see an arithmetic problem that you can do without much trouble, feel free to do it. But if you just want to put it all in a calculator, go ahead. Speaking of putting it in a calculator, we would put in 200,000 divided by, we really don't need these parentheses because there's just one number here. Had you typed this in, you definitely would have needed them. If you're not sure, type them. It's better to have them and not need them than need them and not have them. So 200,000 divided by, parentheses, 1.025, close parentheses, exponent 20. Oh, that's all they need. Gee, we want a $200,000 house later. How much do we need now? The answer, $134,351.45. That's all. Now, if you haven't bought a house yet and you plan on buying a house in your future, this is not how it's actually done. This was just an example to reverse the process to answer the question, what do I need now? What principle do I need now to achieve a certain future value in the future if I'm doing compound interest? So, how do we pay for something expensive? Put down a huge chunk of money, wait 10 years to have a huger chunk of money to buy it? No. We make payments. So in the next video, we're going to talk about something called an annuity. It's a little bit different than a mortgage, so I'm going to step away from the mortgage examples. Well, let's go back to the college problem with the family investing the $5,000 when their child was born, and after 18 years, they didn't have as much as they thought they did. So how can you pay for college when your child is born? Put down a huge chunk of money and walk away? Come back in 18 years and see what it turns into? You could, but A, you may not have a huge chunk of money, and B, that pile needs to get bigger over time. Well, one way a pile of money can get bigger over time is to let the interest grow, but another way is to throw more money on it over time. Hey, here's $1,000. I'll come back in a month and add another 100. I'll come back in a month and add another 100 while it's growing. That type of investment is called an annuity, and we'll talk about it in the next video.